Right, so this episode is going back to the sprite sheets that we were looking at before, and looking at the C# program written to convert the data that you see here into CSV data as seen here. So on this particular example, we have the door frame, left door and right door, and these are the rectangles that describe them with their origins and the size of the rectangles. Now the reason we need these is that when we draw the clips in the monogame version, what we're going to be doing is to load in the entire image and then select a rectangle from it and then draw it onto the screen by kind of, if you like, cutting a section out, a rectangular section out. So we need to know the coordinates to take it from in order to select that section of the image to draw it. So it doesn't matter if it's only like 3 items here. These can be done manually by clicking on these and looking up the layer attributes, get the coordinates from there, and then going to here and getting the boundary size, looking those up. So yeah, it can be done manually, but it's quite an effort. But when you've got one like this, which has a lot of images on it, and if we look at the data that has come from this one, just get this one up, there we are. We have 358 items, and you do not want to be doing that manually. So let's get those out of the way, and we'll show you a program written in C# that does that for us. I'll just start it off so you can see how it works. So you get this, it's a console based application, so you just get the console here. Let me drop that out of the way so that we've got a slightly clearer background. The initial one is to choose the file extension. The reason for that is that you might just want text CSV, or you can make your own up. I've used .data for the files I was just showing you. These are .data, simply so that when these are converted into a SQLite 3 database, we can use the .data to go into a particular table, which is the source rectangles table. So just to show you how it can change it, if you wanted to produce a custom one, let's choose one. I'll just show you how this works first of all. If I just press the enter key, it tells me no, that's no good, so let's put 10 in. That's no good. -1, that's no good, so we've got to put a real number in. So let's choose 1, and we can now type in the extension. Oh, I've just realised I've got a spelling mistake there, look, so I shall fix that. So let's try, it says 3 to 10 characters, so let's try BR. Right, 3 and 10, so that's not going to accept that. What I will do, just to save time, is I'll put in DATA, and now it's accepted that. So it's going to take all of the XCF files that it finds in that directory, and you can convert them one by choosing which one you want to produce the data file for it. So if we choose, for example, the start one, which is 10, we know what it already looks like, but this gives us another chance to do it. So if I press 10, press enter, it writes the file and then comes back to here for us to go through and do another one. Again, it's idiot proofed if I just press the enter key and so on. Let me press 1 to quit, and we can show you how it works. So you need this using is Image Magic, which is from NuGet. So let me show you what that looks like. So we'll go to is it under extensions, I can never remember, tools perhaps, NuGet, there you go. So these are the ones that you want. It's magic.net.core and magic.net Q16 any CPU. I think if you select this one that the core is automatically put in. So you need these, and this is a library specifically designed to read GIMP XCF files. So we'll close that off. So let's see how this works. Now running from static void main here, it uses one library class, which is XConsole. Show you XConsole. This is a library I wrote for doing adventure games. It's a static class, so it just gives you a few more. It sort of extends the console idea so that you can clear it and set the color at the same time. You can clear one particular field. You can get specific inputs from the user. So if you want a Boolean input or a string input or a real number or an integer or whatever, so all this works there. I don't really want to go through how this works, but it's got plenty of comments in, so it should be fairly obvious if you wanted to look through it yourself. So let's go back to this one. So when main starts, it sets a couple of variables here. The image path is left blank. The application path, using the system reflection assembly to get the path where it's running from. Then it calls on this XConsole to produce the header and other things. So if I stop it at the, not that one, if I stop it at the sleep one, I'll do, and we run this, I'll show you what we've got. So that bit has produced the header. So we've got XConsole6 header here, and then you've got the GIMP XCF reader for extracting layer coordinates and rectangle sizes, white on dark red, which we've got here. It'll then sleep for 2 seconds. It'll then clear and do another header which says choose your file extension. File content is identical in all cases, white on dark green. So let's stop that there and we'll run it again. Let's bring that up. So we've now got a different header which says choose your file extension. File content is identical in all cases, CSV. Then it's going to produce this menu. So you can see we've got xconsole6.menu. Select the file extensions you require, and it's going to pass this list of file extensions here, which is custom, CSV, text data, XCF data. You could add more if you wished. So it'll add those in to the menu by calling the xconsole6 menu, and then it will check what the choice is. So if you chose the first one, which is custom, that gives you the ability to type in a new one. So let's stop it at this point here, untick that, will continue to run. Okay, oops, where are we? Oh, it's down here. Right, so we've now got the menu coming up. So this menu is being controlled by the xconsole6 static class. So if I choose one, as I did before, as you can see, it's waiting for us to choose here. Let's just get that out of the way, that's fine. So choice equals 0, so we've chosen custom. It will clear the console, put another header up allowing you to type the contents in, and this time it uses a get string, so that enables us by this is the prompt that it will display, type it, and that's where my spelling mistake is. I won't change it now because it probably won't run because I've made an alteration, but that's just got to change my spelling mistake. In fact, I'm going to do that because it's just annoying me, so I'm going to do that. It will probably die at this point, so let's... Oh, no, it didn't. Right, okay. And it even put... Oh, that's nice. Didn't used to do that. Anyway, we've now got it carrying on. So it says type the extension you require, 3 to 10 characters. The dot is not required. So this thing again calls the XConsole class to, if I press just the enter key, it comes up with that, and so on. So all the idiot proofing is done in the XConsole class. So as I did before, let's type in data. Now see, when I press enter, it's going to go flying past. So let's stop it at this point here, and we'll then hit enter. Right, so the file extension is now set, as you can see when I hover the mouse over it, to .data. The reason we don't need to put the dot in is that we first of all check if the dot's already been put in. So if I had typed in .data, it was going to check here. So if not file extension starts with a dot, then we will put the dot in using file extension equals $. And the file extension, so that would add it in if it wasn't already there. So we've got the correct .data extension now. Then the next stage is to check whether the application path and path text is there. This path.txt contains, if I can I'll have to read it first. It tells you where, or tells the program where to look for the XCF files. So let's run F11 on that one. Okay, so it's read the text from the path.txt, which should be my Dropbox directory. So there we go. So we've got all the where the stuff is at the moment. So that's where it's looking to find the XCF files, and it uses the directory get files using the filter star.xcf. So if I go on F11 and do that, we should find in files we've got a string array of 13 files. There they all are. As you can see, we've got all the XCF files there. If I just hover that over again. So we've got champions, doors, floors, fonts, GUI, items, monsters, stairs, and so on. So we've got them all here. Now, the next thing I wanted to do was to make a neat display. So I've set this int variable here, max file length at 0. And then what I'm going to do next is to go through each of the files in this path using a for each loop here, and if I go through it, it's now going to ask what is the length of each of those files. If it's greater than the current max file name length, which is 0 of course, it's going to set the path to length. So the max file length now is at 13, and then we'll go through it again and again and again and so on, so that we end up with the longest file name that's in the list. So if I stop at that point, run on, we can untick that now. So max file length is now 19, so we know that the longest file name is 19 characters. Then what we can do is to add onto that. So we've got we're going to go through again the same kind of loop. We're going through the file in files one. And then we're going to get an input file and an output file. So let me show you how that's going to work. So in the first one here, the file name is that long one here ending in champions.xcf. So it's going to get the file name, in other words it'll strip all the path out of it and just get champions.xcf, and pad right to the maximum file name length plus 1. So it was 19 characters, so it's going to pad out to 20 characters, so that the input file name is now going to be 20 characters long. So if I press F11, and we can see that input file, as you can see there, is champion.xcf, and then there's about 3 or 4 spaces before the quotes close. So we've got a fixed length string for our file name. And then we're going to do an output file which is the same name, i.e. champions, but with the file extension .data. And then we're going to add to our file list, which we set up here as an empty list of strings, the input file champions.xcf goes to output file, which is champions.data. So if you press F11, so in our file list now, we can check that out. We've got the first one there is champions.xcf with the spaces required to neaten it up, arrow champions.data, and then we're going to insert the list here. Sorry, we go through and create that list. So that file list now is just one. Let me go down to this one and we'll make it spin all the way through. There we go. So our file list now is 13 items, as you can see, with all the they don't look as if they're lined up here because I don't think the font here is monospaced, but it should do once it's displayed on the console. Now we're going to insert at the start of the list the option to quit. So if I press F11, then our file list should now start with quit. There we go. So our first item is quit, and then we've got all the different files. So now we can go down to this while loop. So this Boolean value quit has been set to false. So while not quit, we're going to go round and round and round and redisplay that menu time and time again in order to draw out the choices there. So let's go to this one here, I think, and we'll press the green there. So we've got our menu has come up using again the X console, and you can see these are now quite neatly lined up because we calculated the length of each one and indeed compensated for whether our menu column is a single or double figures. So that it's created those, and then we're going to choose the things now. So if I press 1, it will quit, so obviously we don't want to do that. So let's do the one we did before, which is start. So we'll press 10 on there. Now I better make sure we've got a stop point. Yes, we have. No, that's not the stop point we wanted, is it? No, this is the stop point. Yep, that's okay. So we can carry on. So I'm going to press enter now. Okay, so choice is 9, so obviously it's not going to be quitting. So we're going to go through the loop again. So the string input file is the files that we have already produced. I'll just show you those. So those are the names of the files we've already produced, with choice -1 because choice was 9, so we want the 8th file on here, which is that one, start.xcf, that's the 8th one in, hence choice -1, to string. So if we go down and there we are, so input file is that one, start.xcf, and then we're combining the image path, which is the one that we got from the file path earlier on, so that set that one earlier, and then this path.getFileName with that extension of that file. So if I press F11, so this of course is a built-in function of path, and so we've now got the save file as path plus start.data. So we've got the input file and the save file. It's now going to check whether the save file exists, and if it does, if we've already created one called start.data, it will then delete it, which I believe it does exist. So if you press F11, oh well, yes, I want to let me shift and get out of the console. So if we're going to check now whether the file exists, it does, so we're going to delete it, and now we're using this magic collection. So we just initialize it with a new magic collection with the input file, which is start.xcf, and then we're using the stream writer to write the save file, which is of course the one that we chose as start.data. So the for loop here goes through the magic collection of images. So the images there is a count of 4. Now we know that there are 4 images in them. Those are, let me show you, that would be, oops, sorry, the wrong one. Here, these 4. So we've got door frame, left door, right door, and hash background. Let's get that out of the way as well. So what we want to do with this is to not write into the file anything that starts with a hash, and this is not required now, but at an earlier stage I was using the word image background for the background image, and I was using, if we group them into different groups, such as, let me show you on here, we've got these groups, and I've now put a hash sign in front of group, but I was just using the word group with a colon to determine not to write that into the file. So this is kind of redundant now, but I left it in case I was reading an old file at some point. So we're going through all the images, which are only 4. So we'll F11 there. Now it's asking if the images index label starts with a hash. So let's have a look at the images. There's 4 of them. Let's see the results view. So let's see if we can check on naught. There we go. And then we can see if we can find a label. It's quite a lot of stuff, as you can see, that this one gets out of it. Here we are, hash background. So that's got the hash in it, so it shouldn't write it to a file. So when I press F11, it should skip. Okay, now it's now going to look for door frame C5, because this is the next one that does have something in it. So we're now going to write the door frame C5, sorry, door frame.c5. So what it's doing next is the index, which is currently 3, if the index is greater than 1, it's going to use a write line. So let's F11 that. So that will write to the file and put a new line character at the end of it, so that it produces the first one, like door frame here, and then a new line character to ready for the next one to be written. So press F11 there. Then we go back again, and this time we're going to write leftdoor.l5, and again we're checking whether it's an index greater than 1. And then finally, this should be the final one, right door, right 5. And this time, because the index is 1, because we're going, sorry, I forgot to point out, the for loop is starting at the count -1 and going backwards. So we're kind of rotating through them backwards here. This time we're doing right without the right line, so that the final line in the file here doesn't have, when I press the down arrow, it's not jumping to an empty line, so it stops. So these are right line, and right. Okay, so that's what that does now. F11, and I think that should be it. There we go. And then it redraws the menu, so we'll press continue there. The menu comes back on. This time I'm going to press 1 to quit, and of course it will go through. Let's get this one lined up. So we're going to stop at this choice one again. So we'll press enter, and here if choice equals 0, which it is, F11 quit equals true, which means that this loop won't run anymore, and that's the end of the program. So I hope that's shown you how basically how this works. As I say, I have not gone into the X console. I have put quite a lot of comments in here, so you can kind of make use of if you wish to use this in any kind of other console-based program. It's all there for your use. I've put some stuff at the top which kind of shows you how you can use it. There we go. Right, so let me get that out of the way. So we now know how to create the data for all the image files, and we'll be producing a lot of them, so that let me just show you where they are. Okay, so this is the folder that they were being written to. So we've got all the XCF files. We've also got the PNG files that are created from them. And then when you use the program that I was just showing you, initially all the files are dumped in here. So here is the compiled executable for that, and here are the DLL files for Magic to make sure that that works just by starting. So of course we've now stopped our program from C#, so this should work on its own. Just double click it. There we go. So I'll shut that off because we don't actually need to do it again. And then what I have done from that point is to take out all of the data files and then put them in a separate folder, which is this one. So you can see there is quite a lot of stuff that there's not only is there the data folders, which is the ones that hold the source rectangles, but we've also got some coordinates ones for various things. There isn't one for start because we don't oh yes there is. Let me just put that up as well. Yeah, so what we've got for the coordinates for the start is just the coordinates where they're drawn in the game. So these are the coordinates on the screen where Monogame would draw them to. So again, those are done for all files. Let me just see whether we've got some. This is quite a large one. Let me show you that one. So these are the ones that deal with all the objects. So again, these are just coordinates, X and Y coordinates, where to draw each of those items. Then we've got some normal text files that have got data in them. I won't go through these at this stage. I'll do this when we are creating the database, so you can see why we need a database for all this lot. There is so much information that we need to put it into a database, but at least I've shown you how we can get at least the source rectangles from a C# program. I shall put the these are actually in online, so let me, right, so here is the XCFToCSV. I'll put this link in the description. So here's all the code. I haven't done this as you would normally do to GitHub. I've just literally pasted in the program.cs and the xconsole.cs, so you haven't got like a full downloadable project, but I do describe how to do this in the PDF, which I'll put in. If you go back up to here, oh yes, the PDF will be in I suppose I could put it here. Yeah, I'll do that. I'll add it in here, so you've got the PDF as well. Okay, that's it for this one.